All right. Let's talk about economics. Let's talk about economics. All right. See what? You all have way too much time on your hands. Oh, man. Let's talk about econ. Does everybody have the handout? Okay, all right. So let me explain a couple things about how I'm going to do this review. Okay, in my opinion, the number one key to mastering econ on the FE is understanding how to do time value of money calcs. Okay, if you know how to do that, you're good. Okay, and what I mean by that are the whole F over P and P over A factors and so on and so forth. If you can master that, you're good. Okay, so that's really what I'm going to be spending a lot of time focusing on. I'm also going to show you all some depreciation problems, some effective interest rate problems, and so on and so forth. But I really want to get the kinks worked out on just basic time value of money. Just about everything that you do in engineering econ, and not just in engineering econ, but also on the exam, really sort of revolves around that. Like if you can get, for instance, all of your costs to an equivalent present worth. You know, you can make decisions about one alternative versus another. You can do break-even analysis and so on and so forth. But it all revolves around time value of money calcs. So let me, excuse me. Let me pull this up. So I've got to believe that these are at least somewhat familiar. Okay, so just to make sure everybody's familiar with this, okay, let's do a little bit of mental math here. Okay, let's assume, for the sake of our discussion, something simple, like an interest rate of 10%, okay? So let's say I got $100, and I put it into an account, and it generates interest at 10% a year, okay? So $100, okay? So at the end of year one, how much money is in that account? $110. How much money is in that account after year two? There we go, 121. It's not 120, because the interest is computed based off of your next balance and so on and so forth, okay? So if P represents a present value, so P would be my $100 that I place into the account, all right? F, my future value, is how much money is accrued after so many years and so on and so forth. Make sense? So by and large, the three most common dollar structures that you're going to need to work with on the exam are present values, future values, and annual values. In other words, if I put $100 into that account every year, okay? So what we're going to do is we're going to do a few quick practice problems just to get shake the dust off on our basic engineering economics calcs and make sure that we understand how to use the manual. Speaking of, what I gave you all, this comes straight out of the PDF NCEES reference handbook, okay? How many of you have a downloaded copy of this already? Okay, there's 23 people in the room. Why did only one person raise their hand? You find it at NCEES.org. You have to register and whatnot, but you can download a free copy of the reference manual. I suggest you do that. For everybody who is planning on taking the exam, I'm telling you, having familiarity with this book is important, okay? So you should get a copy of that. So ncees.org. Okay, what I've got here, I actually have the entire handbook, but I've scrolled just to the engineering econ section. So first off, this first page is all of your formulas. So if you were given an interest rate that was odd, you know, like a 1.62% or something like that, you could compute your interest factors accordingly, or your discount factors, if you will. So to give you kind of an idea, just so everybody remembers, so what do we say, $100 into an account at 10% interest, at year one it's 110, year two, 121, so on and so forth. Those factors are a function of, are you trying to convert, let's say, to a given future value given a present value. So if I put $100 into the account now, how much do I have later? If I put $100 into an account now, How much can I draw every year for, so on and so forth. Does that make sense? Yes?
Are you allowed to use Microsoft Excel on the FE?
Nope. So what you need to be able to do is either A, compute these values, or B, use these tables, okay? So you have a series of interest rate tables that have been provided in the manual based on common interest rates. One thing I'll mention about these formulas, if you have an interest rate of 10%, for instance, this first factor, 1 plus I to the n, you do not say 1 plus 10 raised to whatever. It's a percent, so it'd be 1 plus 0.1. Make sense? Everybody good? All right. So let's shake off some cobwebs and let's do some basic examples. All right, so let's do the first one, okay? So give me a second. Let me pull up a little notebook here. Come on. All right. Yes, I want to delete. Yes. All right, you know what? This software has now locked up on me, so we're just going to go off this. Oh, there we go. Okay. Let me pull this up. Okay. So let's start off. Okay. So if I have a one-time amount of $500 invested at a rate of 8% per year at a worth of 30 years, okay, or at a length of 30 years, what's the future worth, okay? So my interest rate is what? 8%, and my number of years is 30, okay? So let's sort of shake these cobwebs off. Does everybody remember doing this? Okay, all right. So, you do, right? Oh, goodness. What?
He said vaguely with a V, but other people started with a V.
Ha, 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 ha. All right, all right, all right. Okay, so let me explain what's going on here. All right, this $500, what is this, an annual value, future what? That's a present value. That's how much I'm putting into the account right now. So if we want, we can say, all right, oh my goodness, everything's all tangled up. Okay, so practice 1. Okay, so our present value is, what was it, $500? $500 at an interest rate of 8% and a number of periods of 30 years. When we usually start with engineering econ, we just say everything's years, and then later on we say, okay, what if you have an interest rate compounded monthly or compounded daily or compounded whatever? Okay, so what we're trying to determine is a future value, okay? So the way that we do this is we say our future value is equal to our present value once it has been converted, okay? Now you can think of this like fractions. What I would need to do is sort of multiply that by this, right? Because you could think the p's would cancel and I'd be left with a future value. I need this factor at, whatever interest rate for how many years, okay? So what I need to do is I need to take $500 and I need to multiply that by the appropriate factor for 8% for 30 years. Okay, so what is that? Now I'm making y'all do some work. 10.0627. Do I have a second on that? So this is 10.0627, which equals what? Say it again.
5,031.33.
Do I have a second on that? 35? Did you use the formula? What's that?
I just plugged through the actual formula.
Oh, okay. So, okay. We'll say 5. It doesn't matter. It doesn't matter. So if you're wondering what's going on here, here's what's going on, okay? And I'm going to break out some Excel that you can't use on the exam, all right? So we're starting out with year 0. We have year 0, year 1, year 2, year 3, so on and so forth. So how many years was it? 30. Okay, so we start out with $500, okay? After the first year, we have $500 plus 8% interest, right? So what I'm going to do is I'm going to take this and I'm going to multiply it by 1.08. So 8% interest is $40 on that. So after the first year, we have $540. So then I get another 8% interest on the 540, right? And then another 8% interest on that, another 8% interest on that. And after 30 years, that $500 matures into $5,031.33 or 35. There's rounding. So if you want to know what those factors are doing, that's what they're doing. They're doing a lot of those shortcut, a lot of that extended math, they're shortcuts, okay? That's essentially what they are. All right? Does that make sense? Any questions on that? Okay. Okay. Now, while we're at it, does anybody remember these? So we would put in an initial deposit of $500 at year 0, and then year 1, year 2, all the way to year 30, and then we can withdraw that. Does anybody remember that? Cash flow diagrams. That's going to become important here in a second. Well, yeah, I have it right there. Oh my goodness. So, yeah, no, I mean, that's right, you know. I mean, this is just a review. Yeah. Everybody okay with this? Any questions? Yes. We're going to... Hold on. Mr. Mitchell. Well, we're doing some practice. We're shaking the cobwebs off. Okay. Now, I'm not going to do this one. You're going to do this one. This next one. If you need to have $800 in a savings account at the end of 4 years, how much do you need to deposit today? Assuming 5% annual interest. You tell me. What's that? Oh, I know. You kidding me? Wait, what? You lost money. You said 972?
Hold on. See how bad we lose interest?
I have no idea. I just threw the problems out. We're just going to do it. We're going to do it live. All right. Any questions? Let's go through it together. So on this one, It's backwards. We have a future value that we know of, what was it? I can't hear you. 800. And we have an interest rate of 5%, and the number of years is 4. What are we solving for? P. So our present value is going to be our future value multiplied by the appropriate factor. And you can think F's cancel, so that yields a P. So I-N. So that is 800 times P over F for 5% for 4 years. And that is 800 times what? That's a good question. Oh, there we go. So what do we get? Say it again. And how many cents? Do I have a second on that? Yeah. All right. It's almost like that was by design or something. It's kind of crazy. Sound good? If I remember correctly, no. Honestly, I'll be honest, I tended to use the factors more than the tables, but the tables are a little faster. Generally, more often than not, you're going to get interest factors that correspond to the tables just because of a time issue. But I would be aware of how to use both, but honestly, if I was a betting man, I would expect more 4%, 6%, 8%, 10%, so on and so forth. Sound good? If it corresponds to what's in the table, yeah, I would go with the table because it's going to be a lot faster. Especially on like annual to future and stuff like that. I mean, these formulas get a little long. So whatever you can do to get a fast answer and to reduce the amount of number crunching, do it. More number crunching, more button taps on this means more room for mistakes, okay? So if you can do it fast, do it, okay? When you look at some of these questions, you'll see, you know, the amount of the lump sum payment is closest to, and there's a good bit of scatter. So do you care about 33 cents versus 35 cents on this problem? No. So do whatever it takes to get the problem done fast. You see what I mean? Make sense? Okay. Now, okay, so this problem is a little different, okay? And I'm tricking you a little bit because we have a 5-year loan, okay, but I have a 12% annual interest rate and it's compounded monthly, okay? Now what we can do is come up with an effective annual interest rate, and there's a formula on doing that, or there's a simpler way of doing it. And the simpler way of doing it would just say, why don't we just take 1% interest for how many periods? 60 periods, right? We have 5 years, but we're talking about a monthly payment, okay? So if we take 1% and the number of periods as 60, we can do this problem quite easily. So a company borrows 100 grand today on a 5-year loan at 12% interest, but it's compounded monthly. So if I take 1% interest for 60 periods, I'm computing my monthly payment. What is that? Is that P? Is that F? What is that? A. So I know P. I need to find A. Tell me what it is. So what? It's 12% interest, but it's compounded monthly. So there's 12 months in a year. So it's 1% per month. So if I just take 1% per month and do it for 60 periods, that'll work. Or I could do an effective interest rate, but I think that's going to end up meaning more number crunching. Does that make sense? We're going to do an effective annual interest rate problem later on. So. Anybody got an answer? 2240? Let's see. So, okay, well, let's see. So I've been given a present value. I need to convert that using the appropriate discount. So that is and that is, let's see, so 1%, A over P, 60, 0.0222, and that is what? So that's how much your monthly payment would be for 5 years in order to pay off that loan. What do we think? Yeah, if you were paying on each quarter. You know what I mean? It gets tricky when you're paying like monthly or paying yearly. Then what I would do is just, you know, convert to an effective interest rate and make sure that your interest rate matches the number of periods, which we're going to do something like that here in a second or a little bit later. So. What do we think? So far, so good? All right. So with that being said, I'm going to give you some time to work on the real first problem one. That was just to shake the cobwebs off. Now, problem one. So the Powerball was won by a single individual. All right. So we'll say it's me because I wouldn't have a problem with that. Yeah, that's who won. All right. The individual was given two choices. Received 26 payments, okay, of $7 million a year. So one this year and one each year following that for 25 years, okay? Or receive a single equivalent lump sum right now, okay? If the state uses an interest rate of 4% per year, what would the amount of the lump sum payment be? Does that make sense? So you could get $7 million now and $7 million for the next 25 years. I'm giving you a hint by saying that. Or get a single lump sum payment right now. So what would that lump sum payment have to be right now for that to be equivalent? This is one of those instances where a cash flow diagram comes in handy. So actually, let me do it like this. All right, so let's track the 26 payments. So we'll say this is year 0, this is year 1, this is year 2, and then year 3, year 4, year 5, year 24, year 25. So that would be 26 payments, right? One in year 0, and then 1, 2, 3, 4, 5, all the way to 25. Okay, so payments of $7 million each year. So this would be 7. I'm just going to use 7. This would be 7. This would be 7. This would be 7. This would be 7. Everybody okay with that? Now, if you remember from engineering econ, annual deposits or annual monies start at year 1, okay? So we actually have two values, okay? We have this. This is an A for $7 million a year, and it occurs for 25 years, and then we also have this. That's a present value of $7 million, okay? So I propose to compute the equivalent present value of the whole thing. We would have to do this. We would say our present value is going to be that annual value times the appropriate discount plus the present value in year 0. So that's going to be $7 million times a P over A for 4% for 25 years. But you've got to also add that additional $7 million. So what do you get when you do that? Oh, okay. What? Did you use the factors in the tables?
No. It's not given. Oh, you need the 25. Oh.
So this is going to be 7 million times 4% at 25 P over A. That's 15.6221 plus 7 million. So what do we got? Say it again. 116 point what? I left all the millions off because I don't feel like writing all those zeros. What's that?
I said you're getting the money.
Well, yeah.
So what if it was, received, we had 27 payments and we said 26?
Then I would use the factor. You could linearly interpolate and you'd probably get close enough, but then I'd probably just use the factor at that point. And again, this is the FE exam. I mean, you know, we're talking about $7 million difference here, so I doubt it would matter. Yes. Yes. Yeah. What do we think? Is this, any questions about this? You just got to be careful with your calculations and make sure you're tracking everything. Okay? Let's look at the next one. All right. If $10,000 is borrowed now, okay, at 10% per year interest, the balance at the end of year 2, after payments of $3,000 in years 1 and 2, will be closest to what? And I'm going to help you out with this a little bit. Easiest thing to do on this is where a cash flow diagram comes in handy. Okay, so this is year 0, this is year 1, this is year 2, okay? So we're borrowing $10,000 at 10% per year interest, okay? So what I might do is this, is I might say, all right, we'll treat that as money going in. So we'll say we have 10,000 going in. So far, so good? Now this is 10% per year interest, okay? So could you move that over to year 2? How would you do that? If we consider this to be now, and this is the future, what would $10,000 now equal in year 2? How would you do that? Turn it into a future value. Everybody with me on that? Okay. Now, this is a loan. I've been paying this off. Okay, I paid off $3,000 in year 1 and $3,000 in year 2. Okay, so what you really have, this is an example of what's called a future value problem. So the easiest thing to do is, you can do this one of two ways. The easiest thing to do is to get everything into an equivalent at the same year, and then you can convert it accordingly. What I'm going to do is I'm going to transfer every value that I see here into a future value. Okay, does that make sense? So I propose that I put $3,000 in here in year 1 and $3,000 in year 2. Does that make sense? Everybody okay with that? So let's talk about the $10,000. Okay, what's the future value in year 2? How do I do that? There we go. So let's come up with some names for this. So let's say this is the loan. We'll say this is payment 1. This is payment 2. So for the loan, the future value is 10,000. Here, I need to move this down, sorry. For the loan, the future value is 10,000, times F over P at 10% interest for 2 years. What is that? $12,100. Everybody okay with that? So let me explain what that means. If I took out a $10,000 loan and I didn't pay a thing on it, after the first year, there's going to be interest accrued on that loan. It's going to be $11,000. All right. After the second year, it's $12,100. Make sense? But I have affected that loan a little bit. Okay. I paid off $3,000 in year 1 and $3,000 in year 2. Okay. So let's talk about that first payment. Okay. All right. Okay. What about that future value? Well, I propose a couple things. Number 1, we're dealing with $3,000 at how many years? 1. All right. Another thing I'm going to do is I'm going to take that as negative because I'm paying off the loan, so I'm chipping away at the balance. Make sense? So what is that going to be? Negative 3,300, right? What about P2? What's that future value? What? It's 3,000, right? Or negative 3,000. Because that was in the year. So in year 2, what's the total balance? Just sum all these up, and what do you get? So this is negative 6,300, so what's that minus 6,300? Here, let me do this. What do you think? Any questions? I mean, how are we feeling? Are we feeling better? Because what is its value in year 2? No. This is at the end of year. This is at year 2. That's a good question. Yeah.
It'd be okay to do it at given A, correct?
You could, but I think that's a little quicker. So now, if you had 12 payments, yeah. What's that?
Why is it just 3,000 for payment 2?
Because it's in year 2. That's in year 2. I mean, what is the value of $3,000 in year 2 if I pay it in year 2? It's just $3,000. What's the value of $3,000 if I pay it in year 1? What's the value in year 2? That's $3,300. Does that make sense? This isn't too bad, is it? Oh my goodness, no, it's not.
Oh, they asked what is the present value of the amount that you're going to pay in year 2. Then you have to take that.
Then that's a future value. Discount it back to present value. Yeah, so that'd be P over F for 2 years. Honestly, one thing I am going to kind of skip over is like break-even analysis or benefit cost analysis. I'm telling you, the simplest thing to do on the exam in general, get everything back to present value. If you get everything back to present value and you're dealing with all values in year 0, you can make, very clear decisions. So for instance, if you got piece of equipment A and piece of equipment B, and they have different depreciations and different salvage values and so on and so forth. If you convert everything to present value, you can make an easy decision as do I buy a piece of equipment A or a piece of equipment B, so on and so forth. It all hinges on being able to do these calculations. So that's why I'm spending a lot of time on them. So, everybody good? Now I got a tricky one for you. Everybody good? Okay. This one's tricky. This is to make sure that you understand cash flow diagrams. If a company wants to have $100,000 in a rainy day fund 10 years from now, the amount of money the company must deposit each year in years 6 through 9 is what? You're like, what? All right. Now, hold on. Okay. The company wants to be able to draw $100,000 at the end of year 10. In order to do that, the company must deposit some value here. Does that make sense? Now, you're not going to like this, but this problem has a little bit of a trick to it, okay? And let me explain. What's that? You got to make a what? Well, hold on. Let me show you something. All right, so let's say I have a generic, cash flow diagram. Okay, so here's a generic cash flow diagram, okay? We treat present values to be in year 0, okay? So here, let me do this. So we treat present values to be in year 0. We treat future values to be in year N, okay? Everybody okay with that? Okay. Now, annual values start in year 1 and they continue to year N. Okay? So this would be an appropriate representation of an annual value, and my future value goes here. Is everybody okay with that? Okay. Here's the strategy on a problem like this. Okay? If you are confused, again, you can get everything to present value if you want and then convert accordingly. I'm going to show you some shortcuts. Okay? I'm going to treat this as my annual value. Okay? I would like to be able to treat this as my future value. But for this to be my future value, I have to move it right here because my annual value starts, here and goes to, let's say, year N. My future value also corresponds to year N. This is 1 year too far ahead. Does that make sense? So I'm going to take this and I'm going to bring it back. So how do I bring that $10,000 back 1 year? Exactly. Exactly. So let me move this back 1 year to right here. So in order to do that, I'm going to take 100,000 and I'm going to multiply it by P over F for 10% for 1 year. And what do we get? Should be 90910. Is everybody okay with that? So if you are confused as to what that means, let me explain. If I put $90,910 into an account, wait 1 year, I'll get 100,000. Is everybody okay with that? What is 10% of that number? 9091? What is that plus 9091? Should be pretty close to 10,000 or 99 or whatever. Yeah. Everybody okay with that? Okay. Now I can compare apples to apples, okay? Because I've got an annual worth or an annual deposit over a period of 4 years, right? I have a future value of 90,910. Now it's pretty basic, okay? Because I'm going to erase this stuff here on the bottom. Now I've got a future value of 90910. I've got an interest rate of 10%. I've got a number of periods. Got a number of periods of 4, and I need to find an annual amount. So A equals F times A over F for the appropriate interest rate and period, which is 90910. That. What do you get when you do that? What'd you do?
I started with, I took the 100 grand that you got at year 10, and then I did P given F at 6, and my P, and then I did A given P at 3.
Okay. Hold on. What?
So I've got 100 grand at 10 going up.
Yes.
Right? And so I need P at 6.
No, it's at 5. Remember, annual worths sort of start in P at year 1. Present value would be here. So just so everybody's aware what we're talking about here, another approach to this problem. So we started out with 100,000 right here. Now what I just did is I moved the 100,000 to year 9 so I could treat it like a future value. What we were just talking about is, well, what if you move it to year 6? You could treat it as a present value. Year 6 would not be a present value. It would be year 5. This would be sort of your year 0, and this would be your 1, 2, 3, 4. Does that make sense? You can do that as well, and you will get the same answer. What? Oh. What's that? Oh. Really? Oh.
We had a man on his way out, so
What does that could mean whatever, or it can mean it's my last chance. I'm gonna, you know.
definitely not the latter. Yeah, I like it too.
I felt like you didn't hear us mention computation.
Is everybody with me so far? Listen. If it takes longer, I know it's tedious, but you could literally convert everything back to present value and then start moving stuff up. I know it would take longer, but it is a simple, straightforward way of getting these problems done. Okay? Well, hopefully you were able to do all the structural analysis and steel design and reinforced concrete design in like 2 minutes. So you got plenty of time. Who taught that crap?
Same guy who's teaching everything else.
What's that? Oh, yeah. Okay. Everybody okay with this so far? All right. Okay. Let's talk about present worths and salvage values and stuff like that. Okay. This is not that hard. This is, and here's another thing. This problem is, I'm only going to talk about machine X. Machine Y would be the same thing, and I'll explain some things about this problem. But I would very highly expect to get an engineering economics problem kind of like this, or at least involving something like this. Okay, so this is, you can call it a salvage value problem, you can call it, what have you, but this is a very common problem on the exam involving purchasing a given piece of equipment. So let's look at machine X. Okay, so it has an initial cost of $66,000. We're saying that's negative because I got to pay that out. Okay, this is also a machine, so it's going to require some money to operate it throughout the year. I mean, even if you buy a car, you got to fill it up with gas throughout the year, right? So it has some annual cost throughout the year. So we'll say that this machine has an initial value of $66,000, and it costs $10,000 a year to operate. Now this machine's going to last me 6 years, okay? And when I'm done with it, I can sell it, and I can sell it for $10,000, okay? So what I want to know is what's the present worth of that machine, okay? Of machine X, okay? So this one isn't so bad, okay? I'm going to walk you through this. This is pretty simple. All right. So here's my cash flow diagram, I have an initial cost of $66,000. I have annual costs of $10,000. So, let's just keep this simple. What is the present value of this quantity right here? It's a trick question, or a simple question. 66,000, right? What is the present value of that? Well, it's an annual cost, right? So convert that into a present value. So I need P over A at 10% for 6 years. Say it again. 43,553, is that what you said? So if I move this over, 43,553. 53? Do I have a second on that? What's up?
Okay. Hold on.
All right. When I'm done with this machine, I can sell it in year 6 for how much? 10 grand. How much if it's 10 grand in year 6, how much is that in year 0? How do I do that? There we go. That's a P over F. So P over F, 10% for 6 years. Move that over. What do I got? Is it going to be more than 10,000 or less than 10,000? There we go. Say it again. Do I have a second on that? Okay. Let's take each of these one at a time. So we don't have to do anything with the 66,000 because that's right now. Okay? The annual cost. So this machine costs $10,000 a year to operate. But if I were to put $43,553 into an account right now, I could draw from that account and that would pay the annual maintenance costs. Make sense? Now, I can sell that machine in year 6 for $10,000. But in year 0, that's not $10,000 in year 0. Discounting that, it only means about $5,640 right now. Because if I took that money and put it into an account, after 6 years, I'd get my 10 grand. So let's think about this. Right now, I have to pay $66,000 to buy it. I have to pay $43,000 to operate it, and I can sell it. And right now, that would only mean $5,600. So what is the present value of this machine? Treat that as a negative, that as a negative, that as a positive. Just add them up. Adding up all your present values. This is a perfect example where getting everything back to year 0 is a simple way of doing an economic assessment. Okay? Think. The $66,000 and the $43,000, that's money out of my wallet. Okay? The $5,600, that's money into my wallet. Okay? So how much ultimately is the present worth of this machine? Just add all those up. Say it again. Negative 103,908. Now, the reason why I threw machine Y on there is one very typical problem on the exam is, which machine should I buy? Machine X or machine Y? Well, calculate the present worth of machine Y. And that'll tell you whether or not, that would be appropriate. Another Another issue associated with this problem, look at this. This machine only lasts me 6 years. This machine lasts me 3 years. So how can I compare the apples to apples? Okay. One way to compare the apples to apples is once you get present value, compute what's called capitalized costs. Everybody remember that? Say what?
The way it was taught to us by Dr. Wade, if I remember right, at the end of year 3, we would purchase machine Y.
I know, that's what I'm talking about. Yeah, that's what I'm talking about. Capitalized costs is basically saying if you took that machine and bought it forever. So every 3 years, buy another machine that lasts 3 years, and so on and so forth. So that would be a true apples-to-apples comparison. Does that make sense? But it's really simple because you just take your present value and multiply it by your interest rate, and bam, there you go. Does that make sense? Your like if you want an equivalent annual worth, just take your present value and multiply that out. What I'm saying is a capitalized cost is basically saying, well, if I look at these two machines, it's kind of hard to compare machine X to machine Y because this machine will last longer. Like imagine I have an operation that's going to run forever, okay? Every 6 years I'm going to have to buy another machine X, but every 3 years I'm going to have to buy another machine Y. This machine may have a cheaper present worth, but it's only going to last for 3 years. That's where capitalized cost comes into play. Is what if I compared apples to apples? You see what I mean? Yes. The idea is how much would it cost to replace this machine every 6 years forever versus how much would it cost to replace this machine every 3 years forever? You see what I mean? It's a simple calc. It's just multiplying by the interest rate.
But if we're trying to pick a machine, when we get machine Y present, we just multiply that by 2 to compare.
No. Yes.
Moving past that, you said a typical question would be which one was better, machine X or machine Y. The question.
All right. What I'm getting at is alternative selection. That's what I'm getting at.
Yeah, but not like that.
That's not what's in this question. I know.
Yeah, but like, the model could literally be
Yes, or it can be like it can be a little simpler than that, or a little. It'd be like, okay, how much would the annual maintenance costs on this machine need to be for the two alternatives to be equivalent? Stuff like that. You see what I mean? No, there won't. No, there won't. But do you see what I mean? Like, what does the salvage value of machine Y need to be so that they have the same present value, or something like that?
So in order to compare them, you usually do like incremental
Yeah.
IRR.
Yeah, and I'm going to skip that for our review. The only other thing I'm really going to cover for the review is, number one, I want to cover effective annual interest rates and depreciation. Beyond that, I mean, I want to make sure you all understand the basics. This is not engineering economics, all over again. So, everybody okay so far? Okay. Okay. Do you all remember this from econ? Oh, goodness. No.
It's like IE plus F.
Okay, all right. First off, it's literally right here on the first page. What? What's that? So literally, here's the idea. Okay. let me explain what's going on here. Okay, so we have 12% per year, but it's compounded monthly. So we can handle this two ways. We could say 1% for 12 months, or we could try and figure out what's an effective annual interest rate that we could use for a single year. Okay, it's not 12 because, as you're aware, from period to period to period, that total balance builds a little bit, right? Remember the $100? After year one, it's 110. After year two, it's 120. It's 121, right? So, so what we're going to try and do is figure out what's an effective interest rate that we could use just years as our period. So it's pretty simple. What do we got? Say it again. So you felt it was either A or B? I'm sorry. M is the number of compounding periods within that year. So if you have an interest rate, so here's a for instance. If I had an interest rate that was 10% per week and it was compounded daily, so M would be 7 because there's 7 compounding intervals per period. Does that make sense? So this is 12% per year, but it's compounded monthly. So that's why M is 12, because there's 12 compounding periods in the space of that year. Oh my goodness. Let me know if you find it. Okay. I have 2 more. Of course not. I'll post them. Okay. I have 2 more problems, and they're pretty straightforward. Let me ask. They really are straightforward. Let me ask. Did you all do depreciation?
Did I do it? No.
All right. Okay, we need to talk a little bit about depreciation, okay? Depreciation is a very common problem that you'll get on the exam, and let me explain. So if you buy some asset, some machine, some piece of equipment, what have you, and you buy it now at the cost of $50,000, after so many years, the value of that asset will tend to depreciate. Okay, so for instance, the latest Call of Duty game, the one that's super brand new and whatnot. How much does that cost? $60. Okay, let me ask you a question. 5 years ago, when Call of Duty's games came out, they were what? Probably $60. Now try and buy one of those games today, and how much are you going to spend? About $5. Make sense? That's a perfect example of depreciation, because what's the newest? World War II. Okay. I'm a Super Mario Odyssey guy. Thank you very much. All right. So in year 0, Call of Duty costs $60, but over time, the value of Call of Duty decreases. Okay. To where year 5, year 6, it's only worth like $5, $10, right? Okay. The same thing is true in engineering equipment, a crane, a piece of automation equipment, what have you. So what we're going to do is we're going to try and figure out what is the book value, what is the value of a piece of equipment throughout its life. So let's say we have a machine with a 5-year life. Now it has a first cost of $50,000 and a salvage value of $10,000 after 5 years. Now we're going to use what's called straight line depreciation for this problem. Straight line depreciation basically says this. It's this simple. All right. In year 0, the book value is $50,000. In year 5, since it has a design life of 5 years, its book value is $10,000. Straight line depreciation. I'm asking you, what is its value in year 3? Yep. You can use the formula or you can use the graph, whatever you want. That's straight line depreciation. Let me ask you a question. How about this? Let's keep this simple. How much does its value change over 5 years? 40,000. How many years? 5 years. So $8,000 a year. 3 years, it's going to decrease $24,000, which means its book value is 26. What do we think? Now, everybody okay with this? All right. Any questions? Hold on. Are there any questions? Are there any questions? Okay.
All we gotta do for this problem is just create a graph.
I'm not kidding. That's straight line depreciation. Yes.
That's probably modified ancillary costs.
Who? What's that stand for?
Modified ancillary costs.
How'd you remember that? Because it's right here. My goodness. Okay. How many of you all remember modified accelerated cost recovery systems? What? What'd you say? MACRS. Okay. Okay. So let me explain modified accelerated cost recovery systems. So this came from some tax law that was passed in the U.S. back in the 80s, and the idea is it gives you an accelerated means of determining book value over time, okay? So let me explain. Bless you. Hold on, where are we going? Okay. So based on given recovery period, so for this problem I think we're using 5 years, we determine the total amount of depreciation. Now, let me ask you a question. Add up these numbers right here and tell me what you get, those 4. There we go. In fact, that will be the same for every one of these, okay? As you go down, this will tell you the total amount of depreciation, and it is not linear, okay? So let me show you something. All right, let's go to problem 7. Problem 7, if I can find it. Problem 7 states we have a 5-year life, so 5-year recovery period, and we have a machine with a $50,000 salvage initial, or a $50,000 first cost and a $20,000 salvage value. So, yeah, salvage. I'm getting over being sick. You bear with me. All right. So using MACRS depreciation, what's its book value in year 2? Okay, so what's its total change in value going to be? Say it again. 30,000. Okay, so watch this. What we're going to do, what we're going to do is we're going to add up, oh my goodness, I hit the pen. Hold on, let me see something. Don't worry about it. Okay. So what we're going to do is add up our percentages associated with years 1 and year 2. In fact, I tell you what, the easiest way to do this, or the easiest way to show it, is to use the software you all can't use on the exam. I'm going to pull up this in Excel. So give me a sec. All right, so let me type out these numbers for year 5, or for 5 years. So what are they? Let's see. We've got 20, 32, 19.2. All right. 1.76. Okay. All right, so this is year 1, 2, oh goodness, I hit enter. All right, and this is year 0. All right, so first off, if you sum these up, you will get 100%, right? So let me show you how this works. Okay, so what's our initial value? 50,000. What's our salvage value? 20,000. Okay, so watch this. So at the end of year 1, we depreciate 20%. At the end of year 2, how much do we depreciate? Total. 52, right? So this is going to be equals that plus that. So that'll be 52, 71.2, that, and that. Everybody with me on that? That's the total amount of depreciation. Now what's the change in value going to be? 30 grand. So what I'm going to do is I'm going to say this. I'm going to say, we'll start off, so this is year 0. We'll say we start off with 50,000, and we'll say equals that, lock that in, minus 30,000 times that percentage divided by 100, because it's got to be a percentage. Bam. So there's its book value throughout that life. Does that make sense? So at the end of year 2, its book value is 34,400. So that is, it's not there. I thought that's what I did. Did I not? Did I screw something up? What's that? I screwed something up, I think. I don't know. Forgive me, I'm sick. That's what it is. What's that? It is a mistake. That's what it is. Let me see. What's that? I'm taking the total percentages and I'm subtracting 30. So I'm starting off with 50,000, and so this would be 50,000 minus 20% of that 30. So I'm going from 50 to 20.
You have to figure in your salvage value. Oh, I guess you did.
I did, yeah. Did I have a typo in there somewhere? I thought that was right. I don't know. That's,
It looks nearly to what?
well, hold on. Is it asking for? Yeah. I tell you what. I will work on that one later. I'll be honest. I thought that was right. I mean, I don't get what's going on. Maybe I'm just a little out of it. I don't know. Maybe I had a typo when I wrote the problem out. Let me see something.
What's your answer?
10, 16, 24, and 30, I think.
So it's close to 30.
Yeah, but if that, I got these out of this old econ book, and if this book really did do that, then I'm not going to be very happy because it would be,
Looking at the equations, it says that DJ equals the factor times the cost. The book value
That's
is
its-
the cost
that-
minus the cost times those factors.
that-
so shouldn't it
but
be-
that's what I did because,
But you did 30,000, not 50,000.
no, but there's a salvage value.
Yeah, because
But it says, it has C, and here C is cost.
Yeah, it doesn't mention anything about if there's a salvage value.
Oh, well, I guess you're right.
Sum of DJ to.
Yeah, but that would assume it would depreciate to 0, which doesn't make sense because you can salvage that out. But, because you can sell and make money in the end. You know what I mean?
Yeah.
So if you,
I know what you're saying.
yeah.
That's all of you.
Isn't that what MACRS does though? Doesn't it assume it depreciates?
No, it assumes it goes to 0. I don't know. I'll look at it later. I'll look at it later. All right. Barring modified accelerated cost recovery systems, forgive me, that was an example I put together about 5 minutes before class. So. And I haven't looked at this stuff in about 10 years. So I think I'm doing pretty good for 10 years.
I hope you'll be just as forgiving when you read my papers.
I had looked at that stuff and I submitted mine class.
All right. Hold on. All right, so hold on. I know everybody's packing up. Are there any other general questions? What are we doing next week? No, there was a what topic? Dynamics. Thermo isn't on the exam. So we'll see how dynamics goes because I'm a structural engineer and stuff sits still. So we'll see you.